Okay, like what I said, in the ODE, we are dealing with one variable. So, if you are finding the solutions, okay, there should be one solutions and it should be unique. Whatever the way, it should be unique. We have seen in the element differential equation as well. Okay, so if it is a solution, it should be unique. It should be exist, and it should be in the region, something like that, isn't it? In the Picard iterations. So, but here we are dealing with two or more. More than two or three or any number, more than two variable. So, and also we are keeping one variable fixed, and there must be some difficulties and differences comes. So it's not always unique. Okay, so we'll see it in later. Similarly, the most general form of solution is called the general solution of PDE. Okay, so since we are having not unique solution, more than possibility solutions, the most general form we call as a general solution. Okay, like what in the OD. Okay, now let me continue. Please everyone join again. There are 39 only. Tell the others to join. Okay, this example is not in your module, so you just better write down each and one. Okay, just try the one and let me explain. Okay, so what it is says is, so let's say this is one of the solutions because of not unique. Okay, not unique. Let me try one example. So let's say this is one of the answer. This is one of the answer. This is one. This is one. See, there are four possible answer for one partial differential equation. Okay, so since in each case you okay, so in these cases we'll have this one. So can you try whether it is these are satisfying, or these four are satisfying for this equation? You know how to do that, no? So if you know one ux comma y, let's say e to the minus x, we only need ux. So what is the ux here? What will be the ex? I mean, partial derivative with respect to x of e to the power minus x. So I think you may remember what is the derivative of e to the power x? Ex or dx or anything? What is that? Can you answer me? Okay. What about others? So what is the differential of this one? E to the power x. Answer for me this one. Okay, okay, good. So e to the power x itself, no? So what about 2x? If you have 2x, so first of all, e to the power 2x, then you have to take the derivative of this function, whatever the function, isn't it? So like that, if you have the derivative of this one with respect to x, we'll have e to the power minus x times minus x differentiated. Partial differentiated. So it will become minus 1. Okay. So this will be minus e to the power minus x. Okay. So can you substitute and find whether it is okay? So for example, if I substitute this function, ux plus u, LHS side. So if I use the LHS side, so my ux will be minus e to the power minus x. plus, what is my u? U is this one. So if I put u minus n, see, minus n plus cancel out, answer will be 0. So it is satisfy my RHS. Similarly, you can find whether this one, okay, satisfying like this. Okay, this is kind of a, I think, yeah, and we have only ux now, so nothing about the y. Okay, so I hope it will be satisfied. So you just check yourself. Okay, keep a space in your notebook or anything, so you can check as a homework. Okay, so likewise, what they are saying, these solution for the PDE are not unique. So there are so many possibilities for one equation. Here also this example 1, 2, 3, 4, 4 solution for only one PDE. Okay, so this is one of the example. Similarly, let's see the second one. So write down the second question also. Okay, so this is one of the example and try yourself. Okay, so likewise you try the this is sorry, the equation will be like this: u2ux plus 3uz. Okay, I think it has changed. Okay, this will be the question. So see whether this one and this one, there are two equations. Okay, two equations are satisfied for this one. Yeah, one equation, the partial derivative, partial equation. Also, they are saying something else. What is it? In fact, so is you, because it has the independent variable y, x, y. Yeah, there's no z. X, y, z is equal to f of y for any function f. U e x y e to the power 2x minus 2z, as well as y of e to the 3x minus 2z also are solutions. Okay, what they are saying is, see, in this equation, we have only y to the power 4. So it is a, give me 1 second. Please copy down the question, okay? So what they are saying is, so we have one solution is y to the power 4. One equation is y to the power minus 5 sine y. So we don't know whether it is, I mean, the u is depend on x, y, z, or only y. We don't know, but the answer only having y, no? Y equation. So they say maybe it is a function of y only. Okay. So this can be written as a function of y only for any function f. But there are situations, this is also one of, let's check this also. Okay. This solution also will be satisfy this one. This also satisfying this one. Therefore, we can't write f of y as function for only these two can be written as, if it is only those two are solution, we can write like this. But there are possibilities. We have this one also solution, this one also solution. Therefore, we can say if I mean u has more than two independent variable, because z is also here, x is there, y is there. So okay, this is what they explaining in that way. Just write down whatever it says, and also try whether this is satisfying, this is satisfying, as well as this and this. There are 4. Not always the 4 solution. There are more than, more than one solution. That's why they say not unique. Also write this equation correctly. 2 to the power ex minus 3u z is equal to 0. Okay. Will I continue, or you need some more time to write down? Or you can take, screenshot and you can use it as later. So that's fine. Okay, let me continue the notes. One more thing we called is as a well-posed partial differential equation. So this is kind of a, you know, okay, let me see what it is. Well-posed PDE means a PDE problem is said to be well-posed if, okay, if it is satisfied this condition, we can say it is a well-posed. So what are the conditions? First of all, there is a solution of PDE satisfying a specific set of boundary conditions and initial conditions. So do you remember what it is? So you have seen initial condition. So this is actually we called as a existence of solution. So likewise in the elementary differential equation, to get the one solution, we have to have one, it should be uniqueness. Second one, existence. Third one, we also talk about the region. So like that, here we are talking three things that we called as existence, uniqueness, stability. Okay, let's see. For I already told you this is not unique solution. That is fine. Okay, we already told one PD may have so many solutions, but here they say if it is well posed, it should be uniqueness. It means only one solution specific to boundary condition unique. There in the EDE we have talked about the initial condition. Am I right? To get the arbitrary, particular solutions, we need to have the initial condition. Why? Because we are having only one variable and thing. Here, for example, let's take our heat equation. Heat equations. So first of all, we need, so if you are heating one, let's say metal rod, okay? If you are heating, you have to know what it was at first. First it was 0 degree or 30 degree. So we need to have the initial condition to get the our arbitrary conditions out. Okay, arbitrary condition out. We need to have the initial condition. Likewise, we also have to have the boundary condition. In this boundary, what is the initially? What is that? In this, for example, let's say at x equal to n, what is the heat? In here, what is the heat? Like that, we call it as a boundary condition. So we can see in our later part. Okay, so there are two things involving here: boundary condition as well as initial condition to get our particular solution. So if it is well posed, we need to have three things. Likewise, this one, we have to have existence. It means it should satisfy the basic boundary and initial condition. Similarly, it should be uniqueness. Okay. And also, even the small change in boundary condition and initial condition and parameter create one small change in the solution. It's a stability solution. Okay. So small change in the boundary condition or initial conditions or parameter create only small change. Okay, so even if we change little bit of initial condition or boundary condition, it should have a small changes in the solution. It be called as a stability of the solutions. Okay, so keep it in mind. So this is we called as a well posed PDE problems. Okay, so let me continue. Okay, I think these all are for lecture 1 things. Now only we are coming for actual lecture 2. Okay, so it is our section number 2, because I told you in our you can see the chapters I have divided like 1, 2, 3, 4. So in the one chapter we have 2 sections. Section 1 is talking about the introduction and classification types and all. And section 2 is talking something formulations. So these terms are very familiar for you from the EDE. So no need to worry. Okay. So same things. So it's going the same way of EDE and ODE. Okay. So you can follow all the things the same way. So it will be very easy for you. Okay. In the section 2, I also numbered as 2.1. But I don't know. In chapter 2 also I can you can put like 1 and 2. So that's that. So 2.1 from the chapter 1, section 2. Okay, let's start that part. So what do you think? Formulation of PDE, like what in the elementary differential equation, what we have done. Do you remember? To form a differential equation, what we have done. Can you answer me? The EDE sections, to formulate the differential equation, we have done one procedure. What do you call? No, that those are solution method. Okay, solutions, how to solve the uh, differential equation. I'm asking how you have formulated. Formula, no, no. How you can formulate the solution to the, what I'm meaning is solution to differential equation, how we get. Okay, we get if we give, for example, in our example, if I give let's say u is equal to e to the power minus x, okay, or a into x plus b into e to the power x, how we can formulate our actual differential equation? What is the steps known as? What is the idea behind it? If I tell you, you will get remember. Okay, that means. Okay, the answer is here. You don't need to go anywhere. He is there. Okay. Partial differential equation can be formed by the elimination of arbitrary conditions, arbitrary functions. Okay, here there in EDE we have used only one thing, elimination of arbitrary constants. Here we're gonna use uh, two ways. Only one is arbitrary constant, other one is arbitrary functions. Both are same procedure anyway. Okay, so we're gonna consider two different ways. Okay, so that's the idea of formulation of PDE. So let me continue. Okay, what it says is, for example, let's see the ideas. If we have, let's say, I have a dependent variable z. Z we can call as a function of x comma y. It means it has two independent variables. Okay, it's dependent on two variables. So we have the following symbolic representation. Okay, so this what you have to keep. These are fixed standard one. Okay, so sorry. These are standard notations. Okay, so keep it in your mind. P to T, they have reserved for these things. Likewise, Ux means da by U over da by X itself for the partial differential equation force. If I write this one, this is indicating these things. Likewise, so if I told you this one already. So we keep Z for dependent variable as well. If you mostly, okay, there are, and they can create even A is equal to if of X, Y, Z. It's depend on the question. But mostly in many authors in the books also, they use this one. That is equal to function of x comma y. This is how you have to read it. Okay, because the z has they don't put z here, they put f function of x comma y. Okay, so if it's so, if I take the z derivative with respect to x, we take as a small p. Okay, don't use capital, not a capital. Okay, that is different. That's for the points and all. Okay, small p. Small p has reserved for this and small q for da bar z over da bar y. Similarly, if it is second one, da bar squared z over da bar x squared is r. Similarly, our xy. Here they don't have the yx, okay? Both for the both they are taking x, okay? Similarly, for y square, they are taking t. So p, q, r, s, t, they have reserved for in this section, they are reserved for these things, okay? So if I write this one, it means dabba z over dabba x, okay? So that's how you have to take this. Now, so let's say our functions, sorry, this. So let's say my function has x, y, z, p, q. It means what? It's equal to 0. It's my equation. For example, I have xp minus yq plus, let's say, pq. Okay? Plus zp, which is equal to 0. This is one of my equation. It means what? X times dabba z over dabba x. One of the partial differential equations, isn't it? So this is minus dabba z over dabba y. Let's say this is S. So S means dabba square z over dabba x dabba y. Of Q means again dabba z over dabba y. Okay, plus Z means small z. Okay. Again Z is Z into P. Okay, dabba z over dabba x. Anything. Okay. Any equation they have written in the common way. Function, it has x, y, z as well as p comma q also as a is equal to 0. We are taking it as an equation number 1. This is we called as a first order partial differential equation. Okay, so this is not possible, isn't it? So if I am taking this as a first order partial differential equation, is that possible to have the first order? No, no. Am I right? What is the order of this equation? Can you tell me? Tell me what is that the first order equation? My equation. So possible for the first order. First order mean? First order means what? Highest derivative is the first order. Highest derivative is 1 is the first order. Then second order, third order, like that. Okay. So first order, all order should be 1. Here we have the highest order will be 2, isn't it? So it's my equation not possible for this. Okay, so that's what I wanted to mean. Am I right? Okay, correct me if I'm doing wrong. Okay, so this will be the general form of function of x, y, z is there. Also pq also should be there. So if it is so only these terms, because p is order of one term, q is order of one term. See, only one term. So this can't be there, this can't be there, this can't be there. So if it is only these terms are available in one of the partial differential equation, we called as a first order partial differential equations. Okay. So and it contains 3 types of variable. Okay, what are the variable with x and y as independent variable and z as a dependent variable? Okay. So in this equation itself, x and y are only the independent variable. Z will be what? Z already told. Z is equal to function of x comma y. So that is not a, this is also dependent variable. Again, p is what? Dabba z over dabba x. Okay, that is not a independent variable. Q is what? Dabba z over dabba y. So that is also not a independent variable. So they are taking these two are the independent variable and this is a dependent variable. These are derivatives. Okay. So if you are having like this equation, we call this as a first order partial differential equation as well as only these that also dependent variable. Now let's see. So P, Q, R, S, and T are partial derivative of dependent variable with respect to independent variable as defined above. Okay, so that's we have seen. So we know what is P, Q, R, S, and T in this section or course. Okay, so wherever you come across, that means that E means always daba the daba X. Okay, right. So let's see some solution of PDE. Okay, using the formulations. We're gonna find the formulation of these first order equations. So let me see. First of all, um, a function, let's say a function f x y z a comma b is equal to 0 is said to be the solution of 1 provided it satisfies 1 completely. So what it says is, so my actual equation is x y z p q. This is my equation number 1. You can see earlier. But if you have, these are okay. Okay. So f, x, y, z, comma a, comma b. When you are seeing the example, you will understand. So this is the solution. So this is the equation. This is the solution. What they mean is my solution in the form of this one. Only the derivative has been solved out. Okay. So actually, what is that? For like I said earlier, if my equation this one in my solution there's no x, it should be any number or anything. Likewise, in the PDE, my solution, for example, z is equal to, I should have anything xy minus ab ax plus by, something like. There's no derivative should be available, should come in our solution. That's what they say. Okay. So this is the solution. If it is the solution of 1, okay. So on differentiating, okay, if we know this solution, okay, what we have done, we have substituted and find out whether LHS equal to, okay. But if you are getting something answer with the arbitrary constant, what we have to do is, we have to differentiate it again, successive differentiation. Then when we get the last equation, from the solution, for example, what I said is, for example, if I have my solution of the partial differential equation, let's say x y square minus a ax plus b by q, whatever. For example, there's no derivative, no. So let's take this one of the solution of the equation. If they ask you to find the equation of this solution, what do you do? You can derivate da by u over da by x, da by u over da by y, or and anything, and just find out the answer. Sorry, this has been changed. I'll write again. Okay. So what they are saying is the function, this one is a solution of 1 provided it's satisfied completely. On differentiating this equal to 0 with respect to x and y, what we have? F is this one. This is my function. Okay. So if I'm differentiating with respect to x, I'll get da by f over da by x will be, okay. So I may get something, for example, let's say my f is equal to function of xy square minus xz. That can become, no, in the solution, or any I mean anything. Okay. AB as a constant. Okay. Or y, like that. So if I am taking with respect to da by f over da by x, what you'll get? So I'll take other element as a fixed one. So I'll get y square minus z. But here you can't take only z. This is like a, what is that? So my course gonna be finished within 10 minutes. So if it is finished, I think we can finish it. Okay. Okay. So here only thing is you have to keep it in your mind. So this z already have the with respect to that is a function of x comma y. So you can't take only z and z as a constant. You have to take this as a uv form. Am I right? So the answer will be, for example, let's say my answer only, let's say my f is xz, x squared z cube, anything. Okay. I'll write again. For example, my answer have x z square or anything. Okay. So if I wanted to have da by for da by x, let's say plus y square. Okay. So I need to take this one as a UV form because that also depend on x. So I need to use x. Okay. If I z square one time plus, then I need to differentiate this part. So x will be there. So if you differentiate x square, what you'll get? 2z times da by z or da by x, no. So what is that? P. Am I right? So y will be nothing. It will be 0. Similarly, da by f over da by y, here nothing. Okay, x will be 0. Okay, but that is x, I think, yeah, 2z times q. Q will become, isn't it? Am I right? So in the x part, x times z square, in this time it will be 0. Plus, I can take other uv form. U part is 0. V part will be, it will come now. So wherever I do, if I wanted to write da by z or da by y, I can use q. Wherever I want to write the da by z or da by x, I can use p. Okay, this one we're gonna use here. Okay, so I think in your notes also change or no, I don't know. But this should be like this. Da by f over da by x plus p time da by f over da by z is equal to 0. This one, this is this equation. Okay. So this equation will be da by f over da by y plus q time da by f over da by z is equal to 0. Okay. So this is the, when you are taking the differentiation of this solution with respect to x, this is this equation. With respect to y, this equation. Okay. So when we are solving these two equations, we can formulate the partial differential equation. Okay. We can see that in the example. After we get these two, let's say this is my equation 1, this is my equation 2. Using some techniques, I can derive my actual differential, partial differential equation. Okay. So let's see the example, then you will understand. I hope you have the notes and everything I have sent you. See whether if it is typing error, just change yourself. Okay. Okay. Now, okay, let's see it in very detail. Okay. So I'll go a little fast because we have only 10 minutes. Okay. Derivation of the PDE by elimination of the arbitrary constants. So let's say this is our solution. Consider an equation number 2. This is the equation where A and B are arbitrary constants. This is what we're gonna take out. So without the A and B, if you formulate the equation, that is our actual equation what we are looking for. So now, so if the session finished, so let's wind up like that. We can meet up in the next week. Okay. So no need to join again. So let z be regarded as function of two variables. So z is equal to f of x comma y. Then differentiating this number 2 with respect to x and y partially in turn, that means x and y, we get this equation da by f over da by x. So here I am using capital F. So da by f over da by x plus p time da by f over da by z. I have explained you this one already. And da by for da by y, q tan da by for da by z is equal to 0. This is our equation number 3. Okay. So eliminating these two constants. Okay. Eliminating two constants a and b from the equation number 2 and 3, we shall obtain the equation of this one. So in this equation, it can be x can be there, y can be there, z can be there, p, q, but not only the a and b. So a and b are arbitrary constants. That is our purpose now. We need to eliminate the arbitrary constants to form this equation from the solution. Okay. Okay. If you see one example, I hope you understand. Okay. So I'll go through. Okay, which is our first order partial differential equation. Similarly, in similar way, it can solve if there are more arbitrary constraints, number of independent variable procedure. Okay, you can go through it and find out what it is. Okay, they are talking about if it is higher order, you have to differentiate again and eliminate the arbitrary constraints and find the answer. Okay. Okay, I'll show you one example. Please write down the question. Okay, this is our question. Okay. So what they are saying is find the partial differential equation by eliminating A and B from the equation. So ED, like ED course, okay? Don't worry about it. Everything are same. So if you are good at it, it will be very easy. Okay. So I'll show you the solution also. Okay. So the solutions begin like this. So if this is my solution, what I need to do? So if I wanted to take out this A, B, see, there are more A and B's. So I can, so this number doesn't matter, okay? You can take as 1. It doesn't matter, okay? I have numbered it from there to here, okay? So you can take that as a 1, equation number 1. Now, so differentiate with respect, partially with respect to x. So see here, in our EDE course, you have used the word differentiate x with respect to x only. Okay. But here we are partially doing now, so we use this term word also. Differentiating the equation number 1 partially with respect to x and y, we will get what? We will get two equation. That means, see here, z is equal to this one. So if you take dabba z over dabba x, here we have the x. So it will be a. There's no x now. So all are constant. It will be 0, 0, 0. So no need to write the zeros. Okay. So it will be only a. Similarly, if you take dabba z over dabba y, you have here only y variable there. So b. Okay. So substituting these values a and b in 5, we see the arbitrary constraint. See, very easily answers. So our equation is having a and b. If you know a and b, you can substitute and find the answer now. So that's what they say. So here you can see in this equation, we need to take out a and b. We have found a is this one, b is this one. Maybe this is p, this is q, no? So you can write, just substitute x time, wherever the a, you substitute this part, wherever the b here. So here a squared, so this one squared. Here b squared, this one squared. Or you can write like xp plus yq plus p square, sorry, p square plus q square. Am I right? So because of this one, you can use this notation also. Okay. So the answer will be, this is answer. Okay, that's all the answer. So the answer will be this one or the other way. Okay. So you can write this one is equal to xp plus yq. Please you make use to this pq also. Okay, this is my answer. This or this. Okay, this is a required partial differential. Okay, can you try this one? Please write down the question quickly. So if the Zoom finish, please you can have it's our last. Okay, you don't need to join again. So please write down the second question and try yourself. It's like your homework. Okay, we can discuss in our next lectures. So next week's we'll have this our on times. Okay, so MTM 1 will be Thursday and Friday we'll have the